So this video is going to look at arc lengths, sectors, and segments, okay? And we'll start off with arc lengths. So we're going to have a look at arcs, okay? Now, if we take a circle, okay, so just a circle like this, and it's got, of course, a center point, and maybe it's got a radius here, okay, just of r units long, and a radius, of course, here as well. Then the distance bound, let's say that this point here is A, and this point here is B. If we take this length along the circumference, then that gives us an arc length. So that little bit in there in red would be the arc length, the arc length of AB. Okay, so that distance along the circumference traveling from A to B. Okay, now enclosed between our two sort of radius lines here, we've got an angle, okay, and that angle can change depending on how big we decide to make the arc length. So we'll just call that angle theta. Now let's say I want to work out how long that arc length is. Then there's a few things that we've kind of got to think about to be able to solve for that length AB along that circumference. So let's think of the arc length as a portion of the circumference. Okay, so we've got the whole circumference of the circle, which would be going the whole way around the circle, but the arc length is just a portion of that circumference. So we'll think of the arc length as a portion. And if I want to kind of think, okay, well, is there a way that I can work out what portion it is that I've got? I can use my angle theta. Okay, the whole circle is a 360-degree circle, but the portion that I'm dealing with is just theta out of that 360 degrees. So the portion part is my theta divided by 360 degrees. I have this many degrees of my entire circle, so that can help us work out the portion of the circumference. And the equation to work out the circumference of a circle is, of course, 2 pi r. So if I want to work out, say, the arc length AB, then I can multiply these two guys together. So I'm thinking about the arc length as a portion of the circumference, and that's how we can generate this formula. So the arc length, and often sometimes that's given the symbol L, okay, that is equal to 2 pi r times theta over 360 degrees. And that's how we can work out the arc length of a circle. We'll do an example. So if we come down here, we'll keep that that little equation there, which we've just come up with, we'll keep that in shot. Let's say that I've got a circle here, and we're going to have, we'll have lines like this, and this can be 3 centimeters long, this radius, which means, of course, this here will also be 3 centimeters long. And let's say that we've got a 70-degree angle sort of in the middle there, and we're going from point A out to point B here, so point A and point B. And we want to work out the arc length, okay, the arc length from A around to B, and we're going to call that arc length L. Well, using the formula, I say that the arc length L, that is equal to, I do my 2 times my pi times my radius. Now my radius in this case is my 3 centimeters. And how much of that circumference do I have? So remember, this part here is talking about our circumference. What portion of that circumference do I have? Well, I have 70 degrees out of a 360-degree circle. And if you were to multiply those together and pop that into a calculator, you would get an arc length of 3.67 centimeters. So that's how we can find the arc length of a particular arc length inside of a circle. And this formula here is a really important one that would be handy to sort of write down or perhaps remember. And if you can, sort of remember where it comes from as well. We're going to have a look now at what we call sectors. So we're going to come down here and we're going to have a look at sectors. So what is a sector? Well, I think of a sector as kind of like a piece of pie. Okay, so if I have my center point in my circle, I can think of a sector as this area which is bound in here. Okay, so kind of like a slice of a pie or a piece of cake or something like that. Okay, now what do I have? Well, I have my radius. So I've got both my radiuses there, and I would have an angle in here, some angle theta. And I'm trying to find out what this purple shaded region is, and that's what we define as a sector. So we thought about this as a piece of a pie, okay, so a piece of pie. But more mathematically correct, we can think of this as a sort of a piece of the entire circular area. Okay, so this is a portion of the area of the entire circle. So before, when we were looking at arc lengths, we were looking at them as a portion of the circumference. However, sectors, we can think of those as a portion of the area. And we can create a formula in a very similar fashion. So if I want the formula for the area of a sector, okay, well, what do? I take my portion. My portion, again, is going to be my however much angle I have out of a possible 360 degrees of angle available to me in a circle. And, well, what is the area? Well, the area of a circle is just pi r squared. So this formula here can help me find the area of a sector. And we came up with that with a little bit of a strategy to think of this as the portion of the area. So, for example, if I have a circle here, perhaps, okay, it's a bit of a dodgy circle, and I have a radius here of maybe 2 meters, and I've got of course, my radius here is also 2 meters, and I'm dealing with, let's say I've got like a 60-degree angle in here. Well, if I want to work out the area of the sector, so going from, so let's say this is point A and this is point B and this is my origin, then we could call this sector maybe OAB, okay, or something of the like, to say that we're trying to find this shaded space in here. So how would I find that? Well, what portion of the circle do I have? I have, so the area here, this would be equal to, so what portion have I got? I've got 60 degrees out of a total 360 degrees available to me, multiplied by the total area of that circle, pi times 2 meters squared. Okay, so if you were to put that all into a calculator, you would end up with 2.09 square meters for that purple shaded sector there. Finally, the last thing that we're going to look at is our segments. So coming down here and having a look at segments now. So for a segment, let's say that I've got this circle here, okay, and we're looking at a very similar situation where I have my radiuses coming out like maybe it's like this, okay, and I've got some angle in here, theta perhaps. I've got my points sort of A and B on this circle here, and I know I've got my radiuses as well. Then if I create what we call a chord, okay, so a chord from A to B, so that's just going from one point on the circle straight over to another point, so we've created the chord AB, then the area of the segment is just looking at this purple shaded space in here. And we need to come up with a way that we can find what that area is going to be. So what could a possible strategy be? Well, we can think of the segment, okay, as the area of the sector. So if I think of the segment as the area of the sector, so this whole space, so if I do it in a yellow highlight, all of this space here, because remember, that is a sector, that's a piece of my pie. If I think of all of the yellow space, and what I'm going to do is I'm going to subtract away the area of the triangle, okay, and I'm going to show you that triangle just now. So if I use maybe a blue pen, this triangle in here, okay, so if I subtract the yellow away from the blue there, I'm going to get the purple. So we're going to do the area of the sector minus the area of the triangle. Now, what is the area of the sector? Well, remember, that is a portion, theta over 360 degrees. That is a portion of my total area of the circle, so times my pi r squared. So that's the formula we came up with before. The area of the triangle, well, remember, that is a half of A times B times the sine of C, okay? And I've done a video on that, the area of a sort of a non-right angled triangle there. And in this case, both our A and our B are going to be the same, okay? They're both R, so a half times R times the sine of the enclosed angle between those two sides, between those two R's, okay? So that is just my theta. And I could write this as r squared as well if I wanted to sort of simplify that formula down a little bit. So that's quite a long formula, but hopefully you understand kind of where it comes from, and it's not too scary for you to be able to regenerate yourself, but a handy formula to have. For example, let's say that I have a circle here, again, a little bit of a dodgy drawn circle, and perhaps it looks something like this, and I've got an angle in here. Maybe it's a bigger angle this time, maybe 120 degrees, okay, and I've got maybe 4 millimeters here and 4 millimeters here, of course, and maybe this is my point A and my point B, and I get this chord come across, and I want to find the area of this segment which sits in here like this. So how am I going to do that? Well, now that we've done the hard work of creating a formula, we just plug the numbers in. So we'll start with the area of the sector. Okay, so I have a portion, 120 out of 360 degrees. I have a portion of the circle's area, so pi times 4 squared. And I need to subtract away the area of the triangle. So minus a half times 4 times 4 times the sine of 120 degrees. Okay, now the sine of 120 degrees is an exact value, so be prepared to potentially have to leave your answers as an exact form, okay, so without going to decimal points and putting it into a calculator. So that's sort of just that added level of complexity that you could see with these problems. But if you were to put this guy just straight into a calculator, you would end up with approximately 9.83 square millimeters. Okay, so that's going to be the area of that purple shaded segment here. So we're going to do a couple more examples now. Hopefully that makes sense, sort of as a bit of an introduction about arcs, sectors, and segments. And we're just going to have a go now at just a couple of practice problems. So we can start off here with question 1, and we'll start with so we've got a circle here, okay, and we're branching from this center point, okay, and each of these radiuses, let's say that they're 5 centimeters long, okay, but this time we're told the arc length. So let's say that this is point A and this is point B. We're actually told that this arc length here is equal to 4.4 centimeters, and we're going to try and find what this angle theta is. So let's start off by remembering what the formula is for the arc length. We say that the arc length L is equal to a portion of my circumference. So it's a portion theta over 360 degrees times my circumference. That's my 2 times pi times my r. Now what I'm trying to find here is my theta. Okay, I'm not sure what that is, but I know the arc length, which is given here, and I know the radius, which is given here. So I can rearrange this equation and solve for theta. So let's substitute some points in. I know that the arc length is 4.4. I'm not sure what theta is, okay, but I know that my radius here is equal to 5. And if we do some rearranging, we can solve for theta. Let's say that 4.4 times 360 is equal to theta times 10 pi. And so theta would be equal to 4.4 times 360 divided by 10 pi. Okay, and if you were to put that into a calculator, you'll see that theta is about 50.4 degrees. So that's how we use the formula in a slightly different way, perhaps this time solving for an angle. I've got 2 more questions. So question 2 here. This time we've got it's a very similar question, but we're going to look at the sector. So we've got a circle, and we've got this radius here, maybe this time of 7 meters long. Okay, and we're told that the area of this sector here. Okay, so we're told that the sector area, that is equal to 43 square meters. And I want to try and find out what this angle theta is. So in a very similar way, we know that the area of a sector, we know it's a portion of the circle area. So it is a portion, theta over 360 degrees, of my circle area, my pi r squared. So what is my area? Well, I know that. I'm told that that is 43 square meters. Okay, and I'm looking for theta divided by 360 degrees times pi times, now my radius here is 7 meters squared. Okay, so I know that I can rearrange this equation now and start to solve for theta. Okay, so if we were to do that, we would multiply both sides by 360, so 43 times 360 360, that is equal to theta times 49 pi. Okay, I should have written that as 7 squared. Sorry, so that's 49 because we've got 2 of those radiuses, so 7 times 7 is 49. Divide both sides by 49 pi, and I see that theta is equal to 43 times 360 divided by 49 pi. Okay, so if you were to put that into a calculator, you would see in this case that theta is equal to approximately 100.6 degrees. Okay, so again, a little question there where we're now solving for the angle, which inside of one of these arc length, sector, segment type questions. Finally, I've got one more which kind of ties together a little bit of everything. So here I've got a circle and I've got my center point, and I'm told that this here is 3 centimeters now in radius, and I come down here and I'm in 3 centimeters in radius. And perhaps I'm told what this arc length is. I'm told that this arc length here is equal to 4.2 centimeters long. But I want to try and find the area of the segment. The sector, sorry, not the segment. So I'm looking for the area of this sector. How can I find that? Well, the area of a sector, so the area of the sector, that is equal to a portion, theta over 360 degrees, of my total circular area, my pi r squared. But I don't know what theta is, okay? I'm going to have to use the arc length to find theta. So let's kind of go on a little bit of a tangent, and let's go and find what theta is first. So the arc length, L, that is a portion of my my circumference. So that's my 2 times my pi times my r. What is my arc length? Well, that is 4.2. I don't know what theta is. That's what I'm trying to find. But I know that the radius here is equal to 3. Now, if you were to rearrange this equation, and I encourage you to do this and put it into a calculator and prove to yourself that here theta is equal to about 80.2 degrees. Okay, so I encourage you to do that and come to that conclusion. However, what can we do now with that theta? Well, that can go into this equation up here to try and find the area of the sector. So the area of the sector here, that is equal to 80.2 out of 360 degrees. So that is our portion of the total area of the circle, which is pi times 3 squared. Okay, now the area of the sector now, if you were to just put this into a calculator, you would come out with about 6.30 square centimeters for the area of that sector. So that's it for this video about arc lengths, sectors, and segments, and hopefully that makes some sense about how we generated those formulas as well as applying them in different types of questions.